So who's done FizzBuzz?
Me.
I have.
I think we all have.
Okay, everyone's done FizzBuzz. Okay, good. So this should be easy. All right, so I'm here in my terminal. So I'm gonna create a folder just on my desktop. So I'm gonna delete it when we're done. I don't need to save it. So how do I create a folder?
And make dir.
Okay,
Name of the folder.
okay.
Enter.
Okay.
If you want to make sure that, just put a ls.
Okay. So I can do ls. I can also, if I have a
Okay.
bunch of stuff, I can do. Does anyone know what this thing is?
Pipe
Yeah.
It looks inside your grep. Yeah.
include, yeah.
So what I've done here is I've combined commands. So pipe allows you to, pipe together or connect different commands. So ls will list all the stuff on my desktop. But if I have a bunch of stuff here and I'm looking for one particular thing and I don't want to like manually go through and see if I have what I'm looking for, I can pipe the output. So if you think of ls as a function, then whatever gets returned from ls will be the input to the following command. So if I do ls pipe, and then there's another command called grep, which is a regular expression. So I'm just going to search for. So I know that I'm looking for a folder called FizzBuzz example. I could type the whole thing out or just part of it. So whatever ls outputs will be input to this. So grep will say, it's basically going to test everything for, do you have fizz? Do you have the string fizz? And it will find, if it finds one, it will show it in the next line. So now I know that I have this FizzBuzz example. So I'm gonna cd the FizzBuzz example, and then I want to open VS Code and start coding.
Code dot.
Okay. Okay, so VS Code is open. I'm gonna open the integrated terminal in the VS Code, and the shortcut is Control tilde. So now I have my terminal here. I can do ls. I see there's nothing here. Okay, so I'm gonna create fizzbuzz.js, and let's start writing this. Well, I guess maybe we should plan a little bit. Should we plan? I don't know. We could just start writing code. So someone explain to me what FizzBuzz is. What is this problem?
Basically, it prints out a string of numbers from 1 to infinity or whatever you set it as.
Okay.
And for anything that's divisible by 15, it prints out FizzBuzz instead of the number. Anything divisible by 3, it prints out fizz. And anything divisible by 5, it prints out buzz.
Okay.
All other numbers are printed.
So if it's divisible by 15, and then what are the other conditions?
If it's divisible by 5, it prints buzz.
Okay.
And if it's divisible by 3, it prints fizz.
Okay. So, okay. So I think that's fairly clear. I think we have a good understanding of what the problem is. So how should we solve it?
Start with function.
Okay,
or for loop.
so function, we'll call it.
Yeah.
Okay, so what are the first questions I should ask about a function that I'm writing?
It's the argument you're taking in.
And
Okay,
what it returns.
so I might even write that above, so. So what are the parameters here?
I guess it takes in the ending number.
Okay, so let's say
Yeah, max.
something like that.
Yes, max number.
Okay,
And it returns the numbers, I guess returns numbers plus the feet, plus the strings.
It really doesn't return anything. We're just logging to the console, right?
okay,
True.
yeah.
True.
Okay, so it returns undefined. So it takes in a number, so I'll go ahead and add that. So you don't have to explicitly write this, but maybe just for the sake of clarity here. So if I want to try running this. Okay, so I didn't get an error, so I think we're on the right track so far. All right, so what should I do next?
I would do a for loop.
Okay. So talk to me about why you want to do a for loop.
The loop through the string, the loop through all the numbers.
Okay. So what's the purpose of that?
So it can go through all the numbers and pull out, once we set the if else statements, it'll be able to pull out the number that's divisible. Like for each number, it'll try the statement that the if statement, like 1, and then it'll try the 15, the 5, the 3. So basically, I don't know how to explain it, but I know what I want to say.
Okay.
Guess a for loop has its own conditionals in it. You declare your variable I, which stands for your indexes, and it kind of helps you go over a range of numbers. It's kind of got its own 3 conditionals.
Right. So there are three components in a for loop. So you have the initial value basically, and then the condition, and then what you want to happen to that initial value for every iteration. Okay, but so let's try to, so the details of a for loop are important, but that's kind of something that we'll worry about later. So at a higher level, we have this function, we have our max number, and so we want to iterate. We know that we want to do something a bunch of times, but I think it's important to just try to verbalize what we're doing and what we're trying to do. We don't even need to explicitly talk about, coding details or JavaScript details right now.
You want to go through each number one by one up to your max number.
Okay, right. So what are we starting at?
1.
Okay, so if we want to formulate this, more precisely, we say something like, starting from 1, I want to iterate over every number from 1 to the max number, incrementing that number by 1 each time. Something like that. And I want to do that because, because why?
each number needs to be evaluated as to whether it's divisible by 5, 3, and 15.
Yeah, right. Okay, so I think we understand what we're doing enough to write some code here. So let's go ahead and do that. So 4, and we're gonna start at 1. So what's our condition gonna be?
Less than max number.
Okay. And then what are we gonna do to I?
Plus, plus,
Plus, plus.
increment it by 1 each time it goes through each iteration.
Okay.
If we do the less than max number, we're not gonna include. the
Yeah,
max
yeah.
You want to go less than
plus
equal.
one.
Okay.
No, less than equal max number plus 1.
Okay, so we have a few different options. We have less than or equal, or less than or equal to +1. So what do
No,
we?
less than. You do I
Oh,
less
I
than
see.
max
Okay.
number plus 1, or you could do less than equal, I less than equal max number.
Okay.
That'll probably be most simple.
Okay. We'll do less than or equal, but you know what you decide to do here is something, you know. There may not be an obvious answer. It might depend on, you know, whatever you're trying to do. But for now, yeah, we'll include the max number. Okay, so now I'm iterating. So have I written this for loop correctly?
Yes.
Are you sure?
Yes.
Is there maybe a better way to be sure?
You could,
You cancel log the numbers to make sure
Okay.
they all come out.
Okay, good. So I might think my code works, but if no doesn't think my code works, then what I think doesn't matter.
So
Okay.
look,
So it looks like this for loop is written correctly, and we're getting the output that we expect, right?
correct.
Okay. All right. So I think that part of what we're doing. So we have this function. It takes in a max num. We're iterating from 1 up to and including the maximum number. So we now have access to all of these different numbers. So what do we need to do now?
Do your conditionals.
Do your conditional statements.
Okay. We'll go ahead and get rid of that. And
If
okay.
I modulo 15
Okay.
triple equal 0.
All right. So let's pause here for a second. So what is this?
The remain, that's the modular.
Okay, so someone else, let's see. Someone else tell me someone who hasn't spoken yet.
Yeah, so the modulus will basically, if there's no remainder when it's divided, it should equal 0. So it should, if it equals that value, it'll output whatever we put under that line.
Okay, so the modulo operator, I can never remember if it's modulo or modulus. The mod operator, what does it give you?
The remainder.
Yeah, so it gives you, so it does division and then gives you just the remainder. Okay, so it's, you know, it's handy for stuff like this. So this is a way of determining. So what about the triple equals? What is that?
That's the strict equality. Oh, I'm sorry, I wasn't supposed to.
Oh, that's fine. Yeah. So yeah, we'll just try and rotate a little bit. So what is strict equality?
Data type and value.
Type and right. Yes. So what is this?
Just value.
Right.
Just the
Yeah, so JavaScript is a very kind of forgiving, maybe too forgiving language. And it will attempt to coerce. So if you use double equals, it'll attempt to do some type coercion. So the number 0 and the string 0 could be equal here because it's comparing, the value, but not the type. And here we're going to ensure that it's actually a 0. It's the integer 0. All right. So if it's 15, we'll just go ahead, console. This will be fizz. Buzz. And what's the next statement I should write?
Else if.
Okay. So do we want else if, or if?
Well, if it.
We want else if because we've got the condition of modulo 5 and then also the condition of 3 next. So we'll need the else if to check that condition as well.
Okay. So
If you just did if, it would just keep running through it and it doesn't need to.
okay, so if we, if as we're looping, max num or I ends up being 15, what would happen if we just had if we had 3 if statements?
It would run all 3 comparisons regardless if it needed to or not.
Right. So we just want to run one of them. So else if. And then,
I modulo you can 5.
okay.
Triple equals 0.
Okay.
Then you would do fizz, a console log fizz. And then you would continue on with another else if, and then I modulo 3 triple equals 0. And then you would console log buzz.
Actually, I think we have our keywords there flipped. 5 should be buzz, 3 should be
Buzz
fizz.
fizz, yep,
Thank you.
sorry. And then you'll need to do one more statement. If it doesn't equal any of those, then you're just going to console log the number.
Okay. And how should we do that?
You could just do an else statement.
Okay.
Else console.log I.
Okay. How's that look?
Yeah.
Like it will work.
Okay. So does it work?
Run it and find out.
Yeah, exactly. So let's run it. So we'll try it with 10. So 1, 2 fizz, 4. So 5 is so buzz, 6 is fizz, 7, 8, 9 buzz, 10. So are we sure that it works now?
Yep.
Not completely because we didn't have
15.
anything that would be divisible by 15. So you would have to increase the initial max num
Okay.
to
So
at least
our,
15.
so our test case, maybe we need another test case here. So let's try.
Go up to 30. Or
Okay.
50.
Okay. Yeah, we can go up to 30. So 15 is fizz buzz, so that looks good. Let's try 30. All right. So are we sure that this works?
Yes.
So one person is sure that this works?
It
Yes.
works for a whole positive integers. I'm not sure how it would react to other inputs, like other edge cases. So if you're asking about like, it works for what we've tried to use so far.
Yes. Yeah, exactly. That's I couldn't think of a better way to say it. It works for what we've tried so far. And we've tried how many things?
We've tried 10, 30, and yeah, we tried what, 2 things, 3 things.
Yeah.
Three.
So,
3.
so is this something that you would be confident? Let's say you're the CEO of Facebook and you have 1 billion users or whatever. Are you confident pushing this to production right now?
No.
No, I have to put some catches in there for when it's less than 0
Yeah, so there are
or less.
so there are all kinds of things we might want to do in terms of like validating input. So I'm not gonna, we're not gonna worry too much about that, but what I want to focus on is the testing. So right now, the way this is, I've written, you know, we have a couple ad hoc tests. So I, as a developer, have done some of this stuff. And if I just push up this code, I'm basically saying, hey, everyone, you can trust me. I ran a couple of spot checks here. This is good. That's probably not what you want to do, and that's not what actually gets done when there's, you know, something at stake. So we're going to talk a little bit about a way of approaching coding, which is more kind of secure. And that is test-driven development. So has anyone heard of test-driven development before?
Yes.
Okay. So what do you know about test-driven development?
And basically, it's basically like it's in a coding environment, it's a separate team that kind of runs a whole different bunch of scenarios on your code to try to catch errors.
Okay, so yeah, so there are often like quality engineers, people whose job it is to test, you know, testing in QA. So that is definitely true. That's not really test-driven development though.
Really, you're writing your code to your test. Like the test is the important part. And then, you know, as long as your tests are passing, the code's good. Like it's kind of a test first approach.
Right. So it's a methodology or way of writing code, which, so what we did here and what let's say the intuitive or kind of obvious way to do it is I write the code as we did, and then I write some tests. So all of our tests were ad hoc and they're not documented, but we did write some tests and we ran some tests. But we wrote our code and then we ran some tests and then like, okay, I'm reasonably sure that this code works now. What test-driven development does is it inverts that process. So you actually write tests first and then you write your code, which seems insane. And it is very weird. It's very weird when you first start doing it, and you know, not everyone likes this, and I think very few people actually do it, but it's a good exercise to do. And even if you don't end up taking this actual approach when you're really writing code, it's a way to emphasize testing, and testing is important regardless of how you actually write the code. So the test-driven development cycle works like, so it's abbreviated as red, green, refactor. So red means there's a failing test, green means the test passes, and refactor is just a way of kind of going through everything again. So as an example, someone tells you to write a function that does something. So you basically you write down all the things that function should be able to do. And then you express that, you kind of document that in the form of tests. So when I call this function with this input, the function should give me this output, things like that. So you write tests like that, and then you write the code to make those tests pass. So initially you write the tests and then you run the test and the test fails. Then what you do is you go to your code and you write just enough code to make that test pass. Once that test passes, you go and you write another test. And then that test should fail because you haven't written the code yet. And then you go back and you write the code and you write just enough code to make that second test pass. And that's the process that you just go through over and over again. And by the time you're done, you have a function and you have a whole bunch of tests. And there are a few benefits of doing it that way. One is that it forces you, we'll see an example, but it forces you to think differently about how your code works. And it forces you to write code in such a way that it's testable. So you have to write code which can actually be tested. And then the tests exist. So you have a whole suite of tests, and those tests serve as documentation, right? So if someone wants to understand what your function does, maybe they don't even have to look at your actual code, at the actual implementation. They can just read your tests. So they read your tests and they know how your function should work. So you have a whole bunch of tests, including edge cases and things like that. So you have a good description and a good understanding. The other benefit is that if you ever want to change, so code is constantly being rewritten and modified and so on. It's basically never the case, unless you're maybe writing something for an embedded device that gets, sent to the moon or something like that. Your code is constantly going to be rewritten. So one problem that you'll have, especially once you have more complex applications, is you'll have a whole bunch of code and different components everywhere, and then you have one little piece, one little function, one little whatever, and you change that, and it's like, okay, that looks good to me, and then everything else ends up breaking. Or you need to change several things, and it's hard to keep track of everything. And if you have a suite of tests, you can always run those tests to see, like, okay, I just broke something. Whatever I did just broke everything, so I can't do that. So you get immediate feedback. There's this scaffolding there that allows you to be confident about any changes that you make. So those are the main benefits of test-driven development as an approach, and just writing tests in general. Okay, so the tests that we wrote here, are there any questions about that first?
No.
No.
Okay. So the tests that we've written, so we could add a little bit of robustness here. So similar to the spec file that we saw from Thursday, we could do I don't know. I mean, we could actually just run a whole bunch of tests. So fizz buzz 1 is buzz 15 or whatever. So we could add more tests, and we could potentially even keep them here in the code. That might not be a good idea, but we could do something like that. But this is very ad hoc, and because testing is something that everyone does, just like developing a web app or anything like that, there are a whole bunch of frameworks available. So this is a problem that people have had to solve over and over again. So you don't really need to start from scratch. So in JavaScript, there are a whole bunch of testing frameworks. One of them one of the more popular ones, and one that is used kind of, it comes with React, which we'll talk about later, is Jest. So Jest, this is an open source testing framework. I think it's owned by Facebook. You know, it's open source, but it's Facebook's thing. So you can come here, and if we want to use this, let's say, okay, I want to write some tests, and I want to write, you know, better tests, and I want to use a framework that gives me some nice features that I can use without having to write from scratch myself. So you can go to the documentation, and learning how to read documentation is a big part of being a programmer. So getting started. So it says install Jest using Yarn. Okay, so we're not going to worry about Yarn right now, or NPM. Okay, good. So we know what NPM is. We have NPM on our machines. So I can run npm install save dev Jest. Is that gonna just work?
I think you'll have to initialize npm prior to that, won't you?
Yeah.
Or is that just installing the?
Yeah, so I am gonna, so this documentation assumes something. It assumes that you already have an npm project going. So this documentation doesn't, you know, it doesn't start from the absolute beginning. It assumes some things. So we're going to start an npm project. So the way you do that, I know that many of you did this already, but it's fairly simple. So npm init. So just like if you want to create a Git repository, Git init, right? You want to create an npm project, you do npm init. And if you do this, it's going to basically give you an interactive menu, and you're going to kind of fill out a form, basically. So you're going to fill out a form with some details of your application. I'm just going to use all the defaults because I'm going to delete this immediately. But if you wanted to actually push this up to npm npmjs.org. Has anyone ever used third-party modules outside of Thursday? Okay, so this is basically an open source repository of people who have written some code or utilities or whatever, and they think, hey, I think other people might get some use out of this. So I can, something like that. I can just do a search for testing. So if I want to look for something that has to do with testing, so simple asynchronous testing framework and so on. Mocha, this is another one. Super test, testing for HTTP servers, Chai. So there's a whole bunch of tests, and here's Jest right here. So there are a whole bunch of options here, like basically an overwhelming number of options. But you can come to npm.js and search for something that you need, depending on what you're doing, and pull in someone else's code. So here's an example. I'll use a different one. Okay. It's just a random one I'm clicking on. It's called Karma, published 7 hours ago. So we can look up here, and here's a README, which will be hopefully describe what this is and how to use it. And then we have dependencies. So what's a dependency?
Someone else's code that you run in your project to make things work. Yeah, it's like relying on someone else, something somebody else has written to make your project better or make it work.
Exactly. So if I write some code and I pull in someone else's code, that's a dependency. So if I want to use Karma's code, Karma relies on 23 other code bases in order to work properly. So that's just something to keep in mind. So if I start a project and I use Karma, then Karma is a dependency of my project. But my dependencies also have dependencies, right? So I depend on Karma, Karma depends on these other things may depend on some other things. So you can get very long convoluted chain of dependencies. And then versions. So what does this tell you? 198 versions.
They've updated their code a lot. It's
Yeah.
like well maintained.
Yeah. So if you are interested in using someone else's code and you're using it in a project that's very important, maybe there's a lot at stake, that might be something that you want to pay attention to. Is this code that someone just wrote and threw up there and then that's it? Or is this an actively maintained serious project? So 198 versions, that tells you that it's maintained, and you can look here at the version history and see, looks like every couple months or so, roughly. Looks like there's some spurts of activity, but maybe every few months something gets updated. So that's good. You can also check some stats out here. So weekly downloads, almost 2 million weekly downloads. That tells you that a lot of people use it, which may or may not. Has anyone heard of the recent Log4j vulnerability? Has that affected anyone? No, okay, that's fine. So there's a recent Java logging library that had a vulnerability which caused a lot of headaches, including where I work. But so that's something. So you use a third-party library. There's a vulnerability in that library, or there's a vulnerability in a library that I use that depends on something else, right? So it's just something you have to think about. And in any case, as a general kind of heuristic, I think lots of other people using it and having something that's well maintained is at least a good initial indication. And then, hello?
Sorry, I just realized I was talking when I was muted. Yeah, I had fun with the Log4j stuff the last several weeks.
Okay, cool. Yeah, I think a lot of people have spent a lot of time fixing that. But it's one of those things where it just shows it's a logging library, so it's everywhere, and there's a serious vulnerability there, so it just kind of throws a hitch into everything. All right, so here we can see that there's a lot of issues and a lot of pull requests. This could be good or bad, meaning that maybe this means that there are problems that aren't being solved. So that's something you might want to take a look at. You might want to take a look at the open issues and pull requests and just stuff to think about. Okay, but in general, that is how you find third-party dependencies or third-party projects in JavaScript. And you can install it, npm I or npm install, same thing, and then whatever that is. So going back to Jest, we went to install Jest here, and this save dev, we'll see what that does in a second. So in order to do any of that, in order to use any of those third-party libraries, well, technically, what you could do if you wanted to use any of these libraries is just go to their GitHub repo, clone their GitHub repo, and then start using it. So you could do that, right? Because the GitHub repo is just some files and folders which you can use yourself. But that's not really extensible. So what you want to do is kind of do this formally, where right now, when you do npm init, we're going to create a document, a configuration document that's going to describe this project. And so if anyone else wants to use this project, they have everything right there. So it makes it clear what's happening. So I'm just going to press enter and go through all the defaults here, but you could type in whatever you want. Yes. So at the end of that, so I did npm init, and then I basically filled out this form asking me for information about my project. And at the end of that, npm spits out this package.json. And the package.json is the configuration file. So this is, high level description of the project. Okay, and so now I have an npm project here. So once I have that, I can start pulling in third-party dependencies. So I'm going to copy this, npm install, save dev, jest, press enter, and let's watch what happens to the package.json. This is taking a minute to download. Okay, so what just happened? What changed?
It added itself as a dependency on your project.
Yeah,
Got a package lock JSON.
yeah. So a few things happened. So just looking at the package.json, we get this new dev dependencies. So again, this is a description of my project. So it's configuration. So if someone else wants to use my project, we're telling them, hey, you need to have Jest as a development dependency. So there's two kinds of dependencies. There's development dependency, which is stuff like testing frameworks. And then there are, let's say, production dependencies, or just regular dependencies, which is stuff you need to make your actual code work. So here, this is a development dependency, and we're marking it that way. So if this code actually gets built and put on a server somewhere, we're not installing Jest, for example, because we don't, it's something we don't need to make the code run. All right, and then this package lock.json. So this one is much, much bigger. Does anyone want to take a guess as to why this is so much bigger?
Is it the dependencies that he added on?
Yes, exactly. So in my project, I only need Jest. So I get one dependency, but Jest depends on a whole bunch of other stuff, and those things depend on a whole bunch of other stuff. So that's what gets included here. So all of those dependency chains get resolved here. So this is huge, right? And this is just one dependency that I have, right? So I added one dependency and I get a 3,000 line JSON file. I also get this node modules. So I think a couple of you know what this is. I've seen people mention it. So someone want to tell me what the node modules is?
I know you don't want to push them up to GitHub. That's usually something you add to your git ignore file.
Yes, that is 100% true. So what's in this node modules? Well, it's all of the code. It's all of the code that's in this package lock JSON. So what happens is, let me, what's this? What happens is I say, hey, I'd like to use Jest as a dependency in my project. So I, do install Jest. And then npm says, okay, you want to use Jest? Well, let me look at Jest. And let me look at everything that Jest needs. And let me look at everything that the thing that Jest needs, and so on and so forth. And then what it does is it actually like clones. It does something like git clone all of these. So it clones all of these repos into this node modules. So this is actually all of the source code for whatever. So here's all these things that braces. I don't know what that is. It's index.js. So here, this is actual code that has been downloaded into this folder that I can then use in my project, or that other things can use in the project. All right, are there any questions? So you should never have to do anything with this node modules folder. You should just let it sit there, basically. You should really only worry about the package.json. You shouldn't change the package lock.json. You shouldn't change node modules. You just need to worry about this one right here. Any questions so far? All right, so let's continue on with the Jest documentation. So Jest is a testing framework and has some, some nice, a nice gentle introduction. So we can copy and paste some of this stuff. So let's get started by writing a test for hypothetical function. So we'll follow the instructions here. So we're going to create a sum.js file. Paste this in. And then we're going to create another file called sum.test.js. And this is going to have the test in there. So we'll do that. Sum.test.js. Okay. And then it says, add the following section to your package.json. So under scripts test, we're gonna put this string in there. So scripts test. Scripts test. So there's already something here by default, and we're gonna replace it with Jest. Does anyone know what this does? So I can replace this. So this allows you to basically run a script here, like a bash script. So I can do, and if I do npm test, it runs that script. So here, Jest is saying, basically, when you run npm test, go ahead and run this Jest command, and Jest will take over from there, and it will do its Jest magic and run your tests. So let's run it and see what happens. So npm test. Okay. So we get some information here. It says there is one test suite and one test. And looks like this one passed. So it's green, it passes sum.test.js. So this is the file that it's in. And here's the test. So let's take a look at the actual test file. So sum.js is not very interesting, but we'll concentrate here. So we're importing this file right here. So we're importing that function, we're calling it sum. And then can someone tell me about the structure of this? I'm gonna call on William.
So it looks like it's running a function called test, and based on what I'm seeing in the terminal, it looks like it's printing out that adds 1 + 2 to equal 3 to pretty much give a description.
Okay.
And then it's basically saying that whenever you're doing that sum function of 1 and 2, you're expecting it to be 3.
Okay.
And if that is the case, then it passes the test.
Okay, good. So let's take a step back, and so test is a function. So what are the first 2 things I'm going to ask you about that function?
What it takes in and what it puts out.
Okay, so
and it takes in, it looks like it takes in a string as its first parameter, and that's the message, and then it takes in an anonymous function.
right. So test takes in 2 parameters. The first one is this string, which looks to be a description of the test, but that's just a guess. And the second parameter is this thing.
An arrow function.
Yeah. So it's an arrow function. So can you pass a function as a parameter to another function?
Yes, because they're first class.
Yes. Yes, you can. So test is something built into Jest. So this is a function that we have available to us, and it takes 2 parameters, it takes a string and it takes a function. And this function will basically, so if I ask what does test return, that might not be clear. It's possible that it returns nothing when we don't do anything with the value. We don't do something like and then do something with that test value. So maybe it doesn't return anything, but whatever it does return, we probably don't need to worry about, at least for our purposes. So it takes 2 parameters. Maybe we're not sure, maybe we don't care what it returns. That's something we could look at if we wanted to, but there's another function here. So expect is another function. So Stephanie, can you tell me about expect?
Expect is telling it what it expects it to receive.
Okay, so I'm asking you
Essentially.
Yeah. So what does expect take in, and what does it return?
Expect is taking in the sum and then the 2 numbers, the 2 arguments that you're providing it. So it's taking in sum of 1 and 2.
So what are the parameters of expect in general? So that there's a specific case here, but if I wanted to describe what expect takes in and what it returns.
Okay. This is that articulation practice, sorry.
It's harder than it looks.
It is. Because from there, I understand what it's expecting when what you're giving it. You're giving it the problem that you are wanting to be solved.
Right. So
and then
let's play around with this. Let's say it's not obvious what it does. So I'm going to run this test and it passes. So what I'm going to do here is I'm going to do see if I can do this. I'm gonna run this again. Here's my console log. And my test passed. So my test still passes. So what do I know about what expect takes as a parameter?
It takes a.
Sorry, you broke up there.
So I was just saying that it takes a function.
Okay. So is res a function?
In
No, it's a
that case,
variable.
variable, yeah.
Yeah. So the sum, this function is being called, which means that the return value of this function is being assigned to res. So expect takes an object or thing, right? So it takes some value. You could replace this with 3. This test will kind of trivially pass, but res. So we know that expect takes a parameter. We don't know, does it take potentially more than one parameter? This is information we need to look at the documentation in order to answer, or potentially the source code. So let's take a look here. So here's kind of an overview of this expect. So test whatever. So we can see here. So what is being passed in here?
Two plus two.
Yeah. So what is that?
Integer.
Yeah. So it's an expression which is going to be evaluated, and then the result will be ultimately passed in as a parameter. So 2 plus 2 will be evaluated. That's going to give you 4, and then 4 will be passed in here. And here, what is data?
What you want evaluated.
Right, but what kind of thing is it? What
It's
type
an
of
object.
An object.
Okay, right. So if we look at a few examples, we can probably figure out what expects as a parameter, right? So we've seen a few examples. It looks like you can pass in primitives as a number. You can pass in an object. So it's always one thing, and it's always, an object or a primitive. So that's probably enough information to actually use this. You can look at the full documentation for expect. So expect. Let's go ahead and look at this example. I'm going to undo this. So if I say that expect takes in, let's say, a value as a parameter, what does it return? So here's a question. So what is this?
True or false, huh?
What is thing?
A variable.
So what can I know about what expect returns based on what's here?
I would say it returns a true or false, huh?
What is this?
A comparison.
Deeply equals.
What's a method that's part of expect?
Yes, it is a method. So what do we know about expect if it has a method?
It's an object.
Yeah. Exactly. So if we see that there's a method attached to this, the result of this function, expect 3, so thing is going to be an object. And this object is going to have a method. So I'm going to go ahead. So here is that object. It's this huge object. And we can see we have, let's see, to be, right? There's a whole bunch of stuff. So we don't need to worry about all of the things that are here. But we can actually take a look at what this thing is. And it turns out that it's an object. And this object has methods. And maybe we don't know exactly how all the internals work, and maybe we don't really care because we just want this to work. But it is possible to look at things and figure out in general terms how they work, even though I've never, I didn't write this library. I haven't looked at the source code. I don't really know anything about it. But there are certain general things that you can, one, you can know pretty, with pretty high degree of certainty from just the code, and two, just making some guesses and looking at a few examples. All right. So I think what we're going to do now is we're going to take a 10-minute break, and then we'll come back and we'll try to redo FizzBuzz, but using test-driven development. So take 10 minutes, come back at 9:20. All right, so now what we're going to do is we're going to redo FizzBuzz, but we're going to write some tests for it. So I'm going to create another file. So I'm going to follow the template here. So I'm going to do fizz.test.js. I'm going to come here. I'm just going to copy all this in there. Okay, so now what I'm going to, so I can't just import some here, so I'm going to have to export FizzBuzz. So I can also, again, look here for the template. So models.exports. So I'll go here, models.exports equals FizzBuzz. And now I'll get rid of these. And I'll call this FizzBuzz. And then a description of this test. So what tests should we do for FizzBuzz?
Let me think of how to articulate that. So 3, 5s, and 15. So you could just pick, I don't know, the 3 or the 15. 3 is the smallest. So if the 3 wasn't, no, the integer modulo 3, if it returns, was it fizz? then that would be expected to return fizz.
Okay, so let's try that. 3 returns is. Okay, and then how could we write that test?
I don't know if that function returns anything. We may have to refactor it to where it does return something in order to test it.
Right, so we wrote this function initially and we did some ad hoc tests, but turns out that this is not really testable. This is not really a testable function. It's not something that we can write, let's say, automated unit tests for. So ultimately our goal here is to write tests that can be automated. So in the, in the real world, you'll have a code base and you'll have a bunch of tests associated with that code. And anytime you try to make changes and, push those changes up, some automated tests will run just to make sure everything's working. So this function can be, ad hoc tested, so we can just look at the console, but that's not really reliable. It's not something that can be automated. So this function, the way you've written it, even though it works, is not really designed in such a way that we can, write automated tests for it. So we're gonna have to rewrite this. So I'm gonna just get rid of all this, unfortunately. Okay, so we're gonna have to start over and we're gonna have to rewrite this in such a way that we can actually test it. So what is the problem? Let me go back here. So what is the real problem with the way that we've written this?
Really not. Go ahead, Steve.
All the output is the side effect console log, and we need a return value.
Yeah. So we have one big function, and all it's doing, ultimately is side effect. So what is a side effect?
Something that happens that's not a return value.
Yes. Basically. Sorry, one sec. Sorry, one sec. Okay. Yes. So a side effect is something. So this is a general term. So a side effect is something that a function does that changes something outside of itself. So console.log changes something outside of itself. It changes something, in my terminal here, for example. But that could be anything. So a function that produces side effects, side effects are inevitable and good, right? They have their place, but if we want to test things, it's very hard to test side effects. You basically can't test things that have side effects. There are a couple workarounds. There are things called mocks, so we could mock that, but that's not ideal. So a better strategy is to think about how can we rewrite this, how can we re-implement FizzBuzz in such a way that we take all of the side effects and basically contain them. So we want to take the side effects and put them just in one place, and everything else we want exposed so that we can actually test it. And the way that you expose things to tests is by returning values. So the goal should be to maximize what are called pure functions. So a function that just does side effects is an impure function, meaning that, basically we can't really rely on it. We can talk in more detail later about, everything that's involved in, being a pure function or an impure function. But The short version is that a pure function, every time I give it an input, it returns a predictable output. So it's almost a pure function could be rewritten as a table, basically like a lookup table. So if I input, so the sum function, where's that? Sum.js right here. This is a pure function. It takes in 2 parameters and it returns that value. So it doesn't change anything outside of itself. And every time I pass in 2 and 3, I'm going to get 5. So you could almost rewrite this as something like, you know, like a table. So input, I don't know. And if I do 2, 3, formatting is going to be weird, but whatever. It's going to be 5. And I could do this. So if I knew in advance every possible input, I could just create a huge table. But you know, that's very tedious, so we don't do that. But in principle, a pure function could be rewritten as a table like this. So that's kind of our goal here, is to write functions as much as possible that are like that. So how could we, first off, let's try and think about all of the things that are happening. So I think this one big function could be broken up into other functions. So let's think about all of the things that are happening in this FizzBuzz function.
Couldn't you save the values in an array?
Okay, so we could write a function that saves, let's say, all of these things, FizzBuzz, and then the numbers in an array. And an array could be returned and checked. So we could do that. So we could write, I'm gonna get rid of it. Well, for now, we'll just use this. So we'll have a function that returns array of values, which will be like FizzBuzz and so on. What else is this current implementation doing?
You can make a function for each if or if else statement.
Okay, so we could write a separate function for each one.
The first thing it's doing is iterating over the numbers.
Okay, so it's iterating. So we'll just do
It's checking each number if it's divisible by the different conditions that you provided.
okay. So it's iterating, it's doing some checks, and we can grab those and put them in an array of values. And then there's one more thing that it's doing.
Printing the output.
Yeah. So we've taken now one function and we've broken it up into 4 functions. So tell me, in terms of purity and impurity, someone tell me about these potential functions we've written.
Guess like you said, you could write them as a table. It takes in a value and you can expect it to return a value, and there's no side effects.
Okay. Is that the case for all of these?
The only one there's side effects is straight side effects is print result, because we're logging it to the console.
Yes, exactly. So what we've done is we've isolated the side affecting part of this implementation. So let's go ahead and rewrite. Let's go ahead and rewrite FizzBuzz. And we're going to use these functions instead. So if you think about the order, so I'm going to do, I think we can just pick any of them, but I think iterating what was the first thing that we do, right?
Yes.
Okay, so and what should iterate do?
Or loop.
Okay, but so
Need a
what's
parameter.
Okay. So
Is
what's
a string. I mean, I'm sorry, it's a range of numbers.
a range of numbers?
Or I guess you could do a range of numbers. You could do 2 parameters, like a min value and a max value, but I think we just did a max value.
Okay. Okay, yeah, so that's a good point.
Well, yeah, because it would take in one number, because if you're going to iterate over it, you're going to provide a starting number.
Well, before in the previous implementation, we assumed that it was 1, but we could, we could potentially make that. So what if we wanted to, let's say, start at 1 by default, but allow for maybe starting at a different number?
Do like min value equals 1, do like a default parameter.
Yeah. So you could do a default parameter. So let's do, oops. Do something like that. And what is this going to return?
I would say an array of numbers ranging from those 2 values.
Okay. So we could do that. Let's say, so we'll return something like that. Okay, so we have this function, we have the skeleton. So let's now write a test that failed, and then go back and rewrite this. So I'm going to do iterate. So we want to return an array of numbers. So how can we write a test here?
In the testing file, you could change the 3 to an array with numbers 1 through 10.
Okay. So I'm going to make this, I don't have to do all that. Like that. So now I'm going to run my test. And it fails.
So we haven't returned anything with the iterate, so it has nothing to compare it to.
Right.
So I think it's always going to throw error.
Yes.
And
exactly. Yeah. So that's kind of the point of the test-driven development cycle is we come up with what we want. What do we want this test to do? And then we implement it. So we write a test that will describe what we want. And then we write something that can actually make that test pass.
So that was the red phase.
Yes. So that's a red phase. So now we're going to switch to green. So now we have this specification. It's telling us what we want. So now we just have to implement something that fulfills that specification. So we could do something like Well, anyone want to tell me what I should do?
First thing you'll need to do is initialize a variable to contain your array.
Okay. So I've got an empty array here.
Now you'll need your for loop.
Okay.
For let I equal min value. I less than or equal to max value. I plus plus. And array nums dot push I.
Okay. Are we done?
And you'll need to return array number.
Okay. All right. So now let's run that test and we'll see if it passes. Let's see. Okay, so this test does not pass. So let's read the output. So this test fails. 3 return fizz. This is the string description we have. It expects received to be expected. And what is this comment telling me? I actually get some helpful text. So this is something that the people who wrote this testing library, this is a problem they anticipate people encountering because they have a specific helpful error message here.
So you take out the method in your test and put triple equals maybe.
Or 2 strict equal,
Yeah, so it's actually, so
changing the method.
so someone, you know, in their own words, tell me what this means right here.
To be is testing for, I think it's called shallow equality maybe, or something like that. And I guess that can't be done with an array. So it's suggesting you use 2 strict equal because of, you know, the code behind that method is designed to test an array.
Good. So what's the difference between, before we were testing an integer, now we're testing an array. So what's the difference between an integer and an array?
Integer is a primitive value and an array is not.
Yes, exactly. So an array works by reference, not by value. So it's telling us here that it's using object.is equality. And if you have 2 arrays or objects, non-primitive types, is means it's the exact same thing. It is the same thing in the same, at the same memory address. So it's not like they're both arrays with the same numbers in it. It's like they are exactly the same. So you don't have to worry about that with primitive types, but here you do. So let's go back here. So common matchers, we have to be, and then here we have a note. To be uses object.is to test exact equality. If you want to check the value of an object, use to equal instead. So here's an example with, in this case, an object, but the same thing applies to an array. So expect whatever to equal, right? So it's not testing that it's the exact same object. It's testing that basically the objects have the same properties. So we'll change this to equal.
Strict equal.
Okay. So right. So here we have 2 strict equal and 2 equal. So I think that depends on whether or not you have an embedded structure, I think. So I think either one would work, but yeah, we'll go with this one. Let's just see if this passes first. Okay, so that passes, but maybe to be on the safe side, you can do this. Okay, so this now passes. So we have our iterate function. Now we're not like testing edge cases or anything. We're actually gonna just not worry about that because it's too tedious and time consuming right now. So we have this iterate function. So what's the next function we should do?
If checks.
Okay, let's do if checks. We call that okay, so what does it take in and what does it return?
I think it's gonna take in your return value from iterate,
Okay,
which is an array right now.
okay, so I'll just do that. And what is it going to return?
Well, you're gonna have to check each item in the array, correct?
Yep, yeah. So I think we're going to have to go through each item in the array.
For in or for of is what comes to mind for me.
Okay, so we can loop through it. So let's say we start with an array. We're going to go through it and check. We're going to do those checks that we have already written, and then what should we return?
I think you could actually just mutate the array numbers into FSBOs and then just test a.
Couldn't,
Like map and filter, yeah.
Okay, it's good. So those are all implementations, but what are those?
Returning another array.
Yes, yes. So we're going to take in an array and we're going to return an array. So let's write another test here. So here we're going to have to add I have to export these functions. So don't worry about the imports right now, but let's do iterate equals. And then this one will be conditional check. So we can say use something like that. Conditional check returns an array. Okay, and let's see. So how can we write that? So I just want to see if it returns an array. So this is a little bit more generic than what we did here. We tested a specific thing. Here, we're just basically checking the return type. Well, I don't really know off the top of my head, so let's look at the documentation. They have a whole bunch of stuff here. So let's see if, I'm just going to do a search for array.
So you're looking for like
Wasn't that
type checking, right? You're looking for like the return value to be in a type of array.
Yeah. Mm-hmm. Array contains. So I'm not seeing anything that's specific. It's that specific.
Maybe search for a type of check.
Okay. We could do type of. So in that case, you could do type of conditional check used to be maybe.
I mean, in the documentation, we should have searched for type of to see if there's a specific check for it.
Okay. So this is too strict equal. That's not really applicable. Okay, so I don't see anything in the documentation that's going to give us a specific method that's going to solve our problem. So we're going to have to use what's available and then kind of make our own thing. Why don't we try this? So expect type of conditional check to be an array. Let's run that. Okay, so this fails. So it expects an array and receives undefined. So let's assume that this test works, and let's write an implementation for conditional checks. So there are a few things we could do. We could do a for loop. I heard map. I heard someone say map.
Yeah, map would go over the entire array itself and run a function on it.
Okay. So I'm going to do, I think map might be a little, I think we'll stick with for loops just for simplicity right now. So let's modify this array in place. So we'll return array nums, but modified in place. So I'm gonna write a for loop for let I equal, how should we write this for loop?
It'll need to start with 0 because the index of the array.
Yes, exactly. So it's a little different than this for loop. So I equals 0, I is less than array nums dot length. So what's next?
You could either do a ternary, or you could do, do a bunch of nested ternaries, or you could do if else statement.
Yeah, so let's stick with the if else again, just for simplicity. We kind of already have that written. I should have saved it, but I'll just rewrite it. So if array nums let's see modulus 15. So how should I implement this part?
Don't you need a variable to accumulate what you're returning? Because we're going to return an array at the end of this function. So you kind of need something to accumulate all your fizzes and all your buzzes.
Yeah, so we can do this in a few different ways, but I think we decide this is not the best way, but we're gonna try to modify array nums in place.
You could splice.
I think we can just replace that specific index, right?
They use the replace method.
Yeah, so if we're gonna modify array nums in place.
Right, so it'd be array nums I equals fizz buzz.
Can we do this?
Yes, arrays are mutable.
Yeah. Okay. So we can do this. So we can just reassign it directly. I'm going to copy this. This is fizz. Is that right? Is it fizz
I
or
think
buzz?
that's fuzz.
Okay.
Fuzz. Do we even need the last one? Because the array's already got the numbers in it. We don't need to change anything. It doesn't
Yeah.
meet any of those conditions.
Right. So that's a very good point. Does anyone see a potential issue if we just leave
Your
it like
two
this?
else ifs are the same.
Oh, that is a problem. Thank you. Does anyone see another problem?
Your fizz and your buzz are the same. Your buzz and
Oh,
buzz are
okay.
also the same.
Thank you. This is what happens when you copy paste. Okay, if we assume that nothing obviously stupid is wrong now, and if there is, please let me know.
You need an else statement to push the ones that aren't divisible.
But they're
I
already,
mean,
they're already there, right?
okay.
I mean, you don't have to agree with me.
Yeah, I agree with you. We're just mutating the same array, so we don't need to change those.
So does anyone see a potential issue? What about the type of data that our array contains?
Okay, so I see what you're saying. So the type of data you have integers, you have numbers, and you're trying to replace them with strings.
Well, are we? So we're replacing some of them with strings, and then the ones that don't fit this criteria, we're leaving as integers. So
We're assuming they're integers though.
Well, they are.
So if we wanted to be more specific about this return type, return. So yes, it's an array, but it's an array of what?
Values.
Values, yeah, but can you be more specific? What type?
Primitive values.
Integers and strings.
Okay, so they're both, yes. So I was trying to get it, they're integers and strings. So we have an array that has two different data types in it. Is that allowed in JavaScript?
Yes.
Yes.
Yes,
It
it is.
It is allowed.
But the name is misleading.
Potentially, okay, so we have a potential issue with maybe the name is misleading. You know, just by the way, some languages don't let you mix types in arrays. But is that going to make a difference for output? Maybe whatever's happening down the line is expecting strings and we're giving it a mix of strings and integers. So I just want to point that out as a potential issue. I don't think it's actually going to be an issue here, but that is a potential spot for a bug to hide. So it's good to think about that. So we have this. Let's say we're fine with it right now. So let's run the test again. And this test still fails. So what? Let me pick on someone. Chris Hicks. Can you tell me about this test failure here?
Let's see. I got a different failure. Let's see. So conditional checks returns an array.
So that's coming from right here. So this is our test description.
Yeah, and then expected an array received a number.
So
It's an,
okay. So you said expected and
it's expecting the string array.
okay, good.
So our type of didn't work.
Yeah, so a couple issues. One is that again, I copied this test, so we're passing it we're passing it a number, but array nums isn't a number. So let's pass it in array. So we have 1, 2, is. Let's run the test again.
Couldn't you use the method is array of array instead of type of?
Okay.
Because
So
type of will return object for anything.
yeah, okay. So before you tell me the
Object
solution,
there,
you just
obviously.
tell me what the problem is. Hello? Who is that? Sorry, I can't see your name with the Google.
Sorry, my microphone isn't working. My microphone's a little goofy. Did you hear me
Yeah,
now?
Anthony. Okay, so so can you tell me what the problem is? So you have a solution, but can you tell me what the problem is first?
Yeah, type of is going to return object because an array is actually an object, right?
Yeah, so this is just kind of
Type
a
of
quirk,
is object.
it's kind of a quirk of JavaScript, where if you check type of for an array, it tells you it's an object. So there's a way around that, as you said.
Yeah, I would use the method is array
Okay.
of array, and it should return true if it's an array.
So this is just a quirk of JavaScript. And then
And it should be true.
okay, so we could do to be true maybe, but let's look at the documentation, see if there's something more specific. Let's see. To be true, so looks like it works. To be truthy, to be undefined. So they don't have something that's specifically to be truthy. So let's use to be and then true. You could also use to be truthy, but this would be more precise. So true. Let's run this again. Okay, so now this passes. Does this say 3 tests passed?
I think it ran your sum.
Oh, yeah, okay, sorry, thank you. Okay, so we have, okay, so I think we're good there. So let's just reorient quickly. So we have this iterate, which is gonna just basically create an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. And then we have a conditional checks, which is gonna return a new array. Actually, so this should not be buzz, this should be just a number. So it's going to return a new array. And we want to do another check, another test here to be more specific.
I would do array length somehow.
Okay, yeah, so there's a whole bunch of tests we could do, and I'm kind of skipping some steps maybe. But yeah, so we could start with some general tests and then get more specific. So does it return an array? Does it have the right length? And then does it have, these specific values? I'm gonna, in the interest of time, I'm gonna kind of skip some steps. So let's get rid of that. I'm just gonna create some spaces here so I can see this better. Okay, so we want to check that it's the same now. So 1, 2, 3 is gonna be 1, 2, fizz. 1, 2, 3 is going to be 1, 2, fizz. So what matcher method should we use?
Is equal.
To strict equal.
Okay, you do the to strict equal or to equal. So why do we have to use this instead of to be?
To be was testing for values.
Yeah. So it'll work on primitive values. Okay, so this test passes. So that looks good so far. Again, we could and should write more tests, but I'm just going to kind of breeze over this. Okay, so we have two functions. We have iterate and conditional checks. So now we have to do something like, so we kind of have our if checks embedded here. So maybe these got combined. That's fine. Now let's, so we have this array of 1, 2, fizz, and so on. So we have a couple options. So we didn't exactly follow this, our plan, and that's okay. So what should we do next? Now that we have this array of values that we want.
So we still want to log everything to the console, so we need another function.
Okay.
This is our non-pure function.
Okay, so let's do this. Function, something like that. So what does print result take in, and what does it return?
Return value from the last function we did.
Okay, so I'm gonna call
Array
it.
nums, which now contains strings and numbers.
Okay, I'll just call it solution array. So we're taking in an array, and what are we returning?
We
Undefined.
shot them in the array. We need to log it to the console, basically is what we're trying to accomplish.
Okay. So this is a little tricky as a check, but
Well, I was gonna say, if we decide that's what we want to test, don't we need to see if Jest has a way to track if we're printing something to the console?
yeah, it does. So I don't want to get into it, but there's something called mocks. It's a little bit more complicated, but you can use something called a mock to kind of intercept the console.log call. That's basically what it does. But here, I'm going to check. So let's say we know that print result is going to return undefined. So let's just
You could check and make sure it returns undefined.
yeah. This is a little bit weird because it's going to return undefined here as well. But we'll go ahead and do this. I'm going to take this one. Let's do, I think there is to be undefined. So let's run this. Okay, that passes. It's cheating a little bit. So now we have this, we have an array. So I don't want to just print out an array. I'd like it to be, formatted a little bit. Just look like
Do for each and then log it to the console with the for each.
okay, let's say I just want one big string.
Two string method. For each two string.
Okay, so what I want is to take this array and turn it into one single string with a space in between each element.
Use array join method with the space as a parameter.
Okay, so oops. Okay, so does anyone see potential issue or maybe something we could improve here? So let's assume we don't have anything like a muck. So let's say we cannot test side effects.
I would say you can, once you've formatted that string, then rather than test for undefined, you can test for that string.
But how could we test for the string?
You have to also add a return statement for formatted. You do a console log and a return statement.
Okay, so we could do console log and then return, but I'm gonna go ahead and say that let's pull this out into its own function that we can independently test. What I'm gonna say is and then I'm gonna export this as well. I'm gonna add a new test here. We'll just stick with something generic for now. That's undefined. So I'm going to check for the type. So I'll do type of to be a string, like that. So again, this is kind of a stand-in for several other tests as well, but I'm going to write this. Okay, so that works. And now I'm going to change my print result. So I'm going to change this to 1, 2, 3. Okay, so these tests now pass. And we should probably also have another function. Are we missing anything here?
Well, you still have your one long string, and that's not really what we're trying to accomplish after, when we print it to the console. So you made that function so you could test the string, but now you have to put it back in a format where you can log each individual thing to the console.
But I see what you're saying. So let's say that what I want to do is just to log it as one big string like this, not one thing on each line.
I think what you're looking for is that we kick this off. We need to call a function.
Yes. So we have all these pieces and we need another function that's going to put everything together and execute it in the right order. So I'll call this run fizzbuzz. So let's just talk about, so what order, this is getting hard to read maybe. If I zoom out, can you guys read this okay?
Yeah.
Okay. So what is the order of events that has to happen? What do we
It's already
call
in its
it?
order, top to bottom.
Okay, so we call iterate. I'll just comment these from here. So iterate, we call iterate, and then we call conditional checks. We call format. We call. Okay. And what does run fizzbuzz take in as a parameter? Or parameters?
Nothing.
Yeah, we
Your min
when
and
we
max.
first did iterate, it could either take one for the max value, or it could take two parameters being the max value and the min value.
Okay. So let's do max val and min val. We'll make one the default. So if we do that, should we change anything anywhere else?
Change that other default.
Yeah, so we could leave this, but we're always going to have a value here, so we don't really need that anymore. Except that, well, we need the parameter. We don't need the default value. Okay, so let's go ahead and iterate. So what is iterate? It wants these two things and it returns an array of nums. So okay, and then conditional checks. That expects array of nums and it returns another array of nums. So let's do and then format array. We'll take, I guess, maybe for the sake of consistency, we'll call this that. We don't have to do that, but and then finally, we're going to print the result. Okay, so we can do that here. Now, of course, there's a problem with this as well, right?
It's not returning anything.
Yeah, so this is also going to be hard to test. Maybe that's acceptable, maybe it's not. Maybe we can come up with another workaround, but I'm gonna stop here. So you can see that, there are obviously things that we could improve, as is always the case, but we started out with one big function and now we have 1, 2, 3, 4, 5 functions that mostly can be tested. So now the internals of our function are exposed and they can be tested. We can write a whole bunch of tests and we can be sure that everything works. Are there any questions?
Chad, I had a question.
Sure.
While we're working through it, I was kind of looking at some FizzBuzz, how other people have worked through it. If you use a conditional operator, because it's checking to see if it's truthy or falsy, would that be testable? Or do you have to break it down like this each time?
How do you mean? Can you?
So I saw a function where it was written out using the conditional ternary operator.
Yeah.
And I didn't know what that was, so I looked it up, and it said that it checks to see if something's truthy, and if it is, it returns this, and if it's false, then it returns this.
Yeah.
Because it's checking if something's truthy in it, could you then create a test for that, or do you still have to have the return value?
Yeah. So the thing is, so a ternary operator will evaluate. So you can do something like. Let me close this.
So yeah, I guess my question is just, is a ternary operator a testable operator?
Yeah. So what is X going to be?
A Boolean. Or I'm sorry, it's a string.
Right.
Either high or by.
Okay. As it's written right now, what is it going to be?
Hi.
Hi.
Yeah. So so we could test this. The problem is you can't directly access something inside of a function. So if this were contained in a function, from outside of the function, I have no direct access to X. I can only do stuff and see X, do stuff with and see X from inside of this function. So the only thing from the outside world, the only thing I can know about this function, basically, I can call it and give it parameters, and I can check its return value. So from a testing perspective, that's all I can do. So if this does return 3, I have no way, I have no access to this from outside of the function. Does that answer your question?
Yeah, thank you.
Okay.